NASA detected a mysterious object speeding toward Earth. Some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
A comet that points in the wrong direction. A chemical profile scientists can't explain. And a series of leaked observatory images that have left even NASA insiders alarmed.
With 0 meaning it's a natural object, like a comet, for sure. And 10 meaning it's definitely a technological object.
3I/ATLAS may be the most disturbing thing we've ever seen from another star.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
And astronomers are alarmed it's going to vanish before anyone can get answers. What telescopes are revealing. At first glance, 3I/ATLAS looks like a comet. It has a tail, it has a coma, and it's moving fast through the solar system. But the deeper the observations go, the more the story falls apart. From early July 2025, NASA's Swift Observatory started detecting OH, a fragment that forms when ultraviolet sunlight breaks down water vapor. This meant that 3I/ATLAS was releasing water. Not a lot, but enough to confirm active outgassing from somewhere beneath its surface. But here's where it gets strange. Most comets that release water also emit a wide variety of gases, especially carbon monoxide, CO, hydrogen cyanide, HCN, and traces of ammonia. But with 3I/ATLAS, what we saw instead was something far more extreme. The James Webb Space Telescope, observing in the infrared, began picking up strong signals of carbon dioxide, making it the dominant gas in the object's coma. And not just dominant, overwhelming. In fact, preliminary spectral analysis published just weeks ago suggests that the carbon dioxide concentration may be significantly higher than any comet ever observed at this distance from the Sun. What that means is this: 3I/ATLAS isn't following the normal chemical playbook. Most comets formed in the outer solar system tend to carry frozen volatiles that vaporize as they approach the Sun, but they usually have a balance in varying ratios. This object doesn't seem to care about the balance. That's not impossible, but it is deeply weird. Because carbon dioxide-dominated comets tend to originate from very different environments, often closer to dying stars or cooler systems with different radiation profiles. And if 3I/ATLAS came from such a system, the implications are massive. This is a chemical fossil from a star we may never see. A sample of a solar system that existed long before our own. Another disturbing signal came from its dust activity. Most comets release gas and dust together. Gas pushes outward, carrying dust particles into space. This creates a tail that usually stretches away from the Sun, pushed by radiation pressure. But early images of 3I/ATLAS revealed something strange: a coma that looked offset, and dust that was venting more directly from the sunward side, not pushed back but projected forward, as if something was actively overriding solar pressure. Now, to be clear, further modeling shows the tail still generally points anti-solar. The original theory that it was reversed has been dialed back, but the offset coma and the sun-facing activity, those are still unusual. And scientists are now exploring the possibility that rotational jets on the sunward side, vents on the spinning nucleus, could be throwing off dust in a highly directed way, almost like small thrusters firing off a rotating body. Which brings us to the next strange clue. 3I/ATLAS might be rotating every 16 hours. And that spin rate, coupled with asymmetric venting, could create all kinds of unpredictable effects, including coma distortion, tail curving, and uneven dust release. But there's still a problem. The coma itself is relatively weak, and the dust being released appears coarse, suggesting that the surface isn't just venting gas, but maybe being broken apart by thermal stress or internal pressure. This isn't just a fast object, it's an unstable one. And that instability makes everything harder to predict. That's what the images are showing. That's what the researchers are racing to model. And that's why this comet has become one of the most studied objects of the last decade. Because every new image raises more questions. Even more alarming, 3I/ATLAS was already active before most telescopes even knew it existed. Archival imaging from May and June 2025, before its official discovery, show gas and dust emission at a huge heliocentric distance in places where sunlight should barely trigger ice sublimation. Swift's UV observations confirmed water-related OH emission far farther out than typical for most comets. That means frozen water and other volatiles are being released at levels and distances nobody expected. Observers using the SOAR telescope also saw temporary increases in brightness before perihelion that don't map neatly to solar heating. Some were dismissed as noise or atmospheric distortion, but they consistently appear in multiple nights. Combine that with the fact that 3I/ATLAS's nucleus size is hard to pin down because its coma is thick and bright, making estimates vary wildly. Some estimates put it under a kilometer. Others suggest it may be several kilometers wide. If the larger estimates are right, then the surface area releasing gas and dust must be massive to generate the observed coma. So what do these early, far-out activities mean? They hint at a volatile inventory much richer than typical comets. They imply a comet that stores more material near its surface, or has a structure that lets volatiles escape even when cold. That makes the current strange behavior less surprising and more urgent. If 3I/ATLAS was already active so early, then missing any part of its ionic flares, fragmentation, or surface eruptions might mean losing what scientists call pristine data, clues to its origin that will never repeat. Signatures that shouldn't exist. When most people hear the word comet, they think of something bright, icy, glowing blue or green as it crosses the night sky. But scientists don't just study what comets look like with the naked eye. They use polarimetric instruments to measure how light reflects off their surfaces, and those reflections can reveal what a comet is truly made of. In the case of 3I/ATLAS, what we're seeing doesn't fit the pattern. In August 2025, a team of astronomers using polarimeters at multiple ground-based observatories released their early results. They found that the degree of negative polarization in the coma was unusually high. That might sound abstract, but here's what it means. The way light was bouncing off the dust around 3I/ATLAS matched more closely with trans-Neptunian objects, dark, primitive bodies from the frozen edges of our own system, rather than with active comets. In other words, this thing looked more like a lost Kuiper Belt object than an interstellar comet. And yet, it's interstellar. That shouldn't happen. What's more, the spectral data from multiple observations showed a rapid color shift. The coma began taking on a greenish hue, not unheard of, but definitely rare. This is usually caused by diatomic carbon or cyanogen gases fluorescing in ultraviolet light. But in 3I/ATLAS, the presence of those gases was not strongly detected. So where was the color coming from? One possibility? Nickel, iron, and other metals embedded in the dust particles. Another possibility is the electrostatic effects from solar-wind interactions changing the glow of the coma itself. Neither explanation is fully confirmed. But the color signature of this object is not just unusual. It's hard to explain with what we currently know. As 3I/ATLAS approached the inner solar system, its magnitude increased, but not smoothly. It's been exhibiting microflares and sudden dimming, suggesting surface shedding or jet eruptions happening at irregular intervals. This behavior is still being analyzed, but it could point to structural weaknesses in the nucleus or something else entirely. When you add it all up, from the abnormal polarization, the unexplained color, the flickering brightness, you're left with a picture that isn't just rare, but confusing. The truth is, no one's quite sure what this object is really made of, and that uncertainty is not going away. 3I/ATLAS is accelerating toward its closest pass to the Sun. And when that moment comes, it will vanish behind it, completely hidden from Earth's view. We won't be able to see how it reacts. We won't be able to confirm what it's made of. And if it sheds gas, fragments, or explodes under solar pressure, it will happen out of sight. And the next time we see it, it might be too late. Cosmic age. Even stranger than the color, still more unsettling than the tail behavior. It's the chemistry and age of 3I/ATLAS. These are the parts many scientists believe could force a rethinking of how objects form in deep space. Spectroscopic images from James Webb and SPHEREX show the comet's coma is flooded with carbon dioxide at levels rarely seen in comets this far from the Sun. Recent studies suggest a carbon dioxide to water ratio up to 8:1, that's ground shifting. This ratio points to two chilling possibilities. Either 3I/ATLAS formed near a CO2 ice line in its parent star system, where CO2 solidified in huge amounts, or its water is being held back by a thick, insulating crust. Both suggest extreme conditions. On top of that, polarimetric studies, which measure how light bounces off dust grains, have found negative polarization deeper than any known comet or asteroid at certain angles. A recent paper reported a minimum polarization value around -2.7% at small phase angles, something seen only for a few trans-Neptunian objects, never comets in our solar system. That signals dust and ice mixtures, unlike what comet models expect. Orbit and motion data show 3I/ATLAS is moving fast, on a hyperbolic path, one that could only come from interstellar space. But more than that, its trajectory and spectral fingerprint hint it may originate in what astronomers call the galactic thick disk, a region populated by ancient, low metal content stars. If so, 3I/ATLAS could be older than the Sun by billions of years, maybe 7 to 9 billion years, if preliminary estimates are right. That makes it not just a visitor, but a relic. This combo, unheard of CO2 dominance, strange dust/ice mix, extreme polarization, and deep age adds a layer of mystery that no comet in our solar system carries. It doesn't just misbehave, it challenges how we think comets should behave, where they come from, and what materials exist in other star systems. And all of this is happening now, while telescopes race the clock, observing light that could vanish behind solar glare. Whatever secrets 3I/ATLAS holds in its ice, in its dust, in its ancient chemistry, we might already be losing them. What the internet got wrong. Let's start with the most viral claim about 3I/ATLAS, that its tail is pointing toward the Sun. This line exploded across social media as soon as the first press renderings of the comet went online. It was repeated in video essays, short-form TikToks, and even made its way into insider leaks. The idea that the object's tail pointed in the wrong direction felt like a smoking gun, a cosmic red flag. Proof that this wasn't a comet at all. But science says something different. Yes, early images showed a coma that looked slightly sunward. But coma orientation isn't the same as tail orientation. The actual tail of 3I/ATLAS is anti-solar, pointing away from the sun, just as expected. That's been confirmed in multiple studies. So what caused the confusion? Part of it is the way 3I/ATLAS vents material. Instead of smooth, symmetrical outgassing from all sides, it seems to have localized jets firing mostly from the sun-facing side of its nucleus. That creates a bright spot in the coma, one that looks like it's pointing toward the sun, even though the true tail, the dust trail, is being pushed away like always. It's not a reversed tail. It's an optical illusion caused by directional venting and spin. Another popular claim was that no gas had been detected coming from 3I/ATLAS, that it was only releasing dust, and that this somehow proved it wasn't a real comet. Again, not true, not even close. The Swift Observatory picked up UV signatures of OH, which forms when sunlight breaks apart water. There was also the infrared data from the James Webb Space Telescope, showing high levels of carbon dioxide in the coma. These are confirmed detections. The object is venting gas. It just happens to be dominated by carbon dioxide, which is less common, but not unheard of. Probably the most dramatic myth is that 3I/ATLAS was following a trajectory so precise it had to be calculated, that it would pass by Mars, Venus, and Jupiter in a straight line, almost like it was visiting planets on purpose. Now, the truth here is more nuanced. Yes, 3I/ATLAS will pass near several planets. Yes, those alignments are interesting, but close, in astronomical terms, is relative. It won't be buzzing their atmospheres or flying through rings. We're talking about distances like 0.3 to 0.7 astronomical units, millions of kilometers. That's close enough to study gravitational effects, sure, but not so close that anyone serious would call it suspicious. Harvard's Avi Loeb did note that the trajectory was noteworthy, especially if it were artificial. But he also clarified that there's no current evidence of such intent. The planetary alignments are worth analyzing, yes, but they do fall within expected ranges given 3I/ATLAS's hyperbolic path. Astronomers are alarmed. It's one thing for science YouTubers to call something alarming. It's another when actual researchers, the ones who have access to the raw data, say the same thing. That's exactly what's starting to happen with 3I/ATLAS. Across private research forums, telescope teams, and planetary science groups, a consistent theme is starting to emerge. We may be watching a once-in-a-lifetime object, and we're not fully ready for it. The first concern is about timing. 3I/ATLAS is currently accelerating toward perihelion, its closest point to the Sun. And during that exact moment, late October 2025, it will pass directly behind the Sun from Earth's point of view, which means every major telescope on Earth, and even many in orbit, will be blinded by solar glare. This isn't a small window. It's a total observational blackout. And it's happening right when we'd expect the most dramatic behavior. And for 3I/ATLAS, a potentially unstable, heavily carbon dioxide-driven, fast-rotating body, this perihelion could be everything. But if it happens while we're blocked by the Sun, we may miss it completely. That's not just bad luck. That's scientific loss. Astronomers have started coordinating with spacecraft teams. NASA's Perseverance rover, the Maven orbiter, and even Juno near Jupiter, hoping one of them might have the right vantage point to capture critical images while Earth-based telescopes can't. But it's a long shot, and if they miss it, the data is gone. The second concern is about fragmentation. Some researchers believe 3I/A TLAS may already be showing early signs of stress. The light curve is inconsistent. Dust venting is uneven. The coma has fluctuated in shape and brightness more than expected. If it starts to break apart, like Comet Borisov did, we may see a cascade of internal structure collapse. That could be the very moment we finally understand how these ancient objects are built. Or it could be another mystery lost to timing. And the third concern is bigger. It's about what happens after. Because once 3I/A TLAS rounds the Sun and becomes visible again in November and December, we'll only get a brief window before it fades. Its brightness will drop fast. Its distance will increase. And we may never see another one like it in our lifetimes. Some astronomers believe it may have originated in the thick disk of the Milky Way, a population of stars and debris that predates our own system. If that's true, then 3I/A TLAS isn't just a comet. It's a relic, a frozen messenger from a stellar environment that formed billions of years before the Earth. And if we let it pass without catching what it has to tell us, that's not just a misjudged chance. That's a moment we won't get back. What makes 3I/A TLAS different? When astronomers first discovered D3I/A TLAS, they were excited. Another interstellar object, the third in human history, entering our solar system, carrying the chemical secrets of a distant star system. That alone was enough to make telescopes scramble. But it wasn't the object's presence that shifted the tone from excitement to panic. It was how it acted. We've seen interstellar visitors before. In 2017, there was Oumuamua, long, thin, tumbling through space, accelerating without a visible tail, and leaving everyone confused. In 2019, there was Borisov, a comet that looked much more traditional, until it fragmented near the Sun and exposed strange internal properties. Both were mysterious. Both challenged assumptions. But 3I/A TLAS isn't like either of them. And that's the problem. Unlike Oumuamua, which had no coma, no tail, and no clear source of acceleration, 3I/A TLAS has all the classic signs of a comet, but it still refuses to follow the rules. Its rotation seems to drive activity that causes abnormal behavior in the coma itself. None of those traits match Oumuamua, and yet somehow it's just as confusing. Unlike Borisov, which showed a relatively balanced mix of water and cyanide gases, and eventually broke apart as it passed close to the Sun, 3E/A TLAS is holding itself together, at least for now. It hasn't fragmented, it hasn't collapsed, and it's moving faster than either of the previous objects. Its escape trajectory is more extreme, and the chemical signature it's leaving behind is harder to categorize than either of its predecessors. It doesn't follow their patterns, but it doesn't follow our patterns either. The final window. On October 29, 2025, 3I Atlas will reach perihelion, the point in its orbit where it passes closest to the Sun. That's usually when activity spikes for a comet, when volatile ices erupt from inside, exposing the chemistry buried beneath the crust. That's when brightness increases, gas emissions shift, and in some cases, the entire nucleus fractures and explodes. We've seen it before, but this time, we won't see it at all. Because at the exact moment 3I/A TLAS reaches perihelion, it will be positioned directly behind the Sun from Earth's perspective. No telescope, not even James Webb, will be able to observe it. The sun's glare will block every instrument we have. And when it finally emerges from the other side, everything could be different. Whether it fragments or stays whole, whether it erupts or remains quiet, we won't know what happened while it was gone. Preliminary trajectory data suggests 3I/ATLAS came from the Milky Way's thick disk, a region populated by ancient stars, dense with metallic remnants and pre-solar chemistry. If that's true, this object could be 7 billion years old, 2 billion years older than our Sun. It could have formed in a completely different stellar environment, around a star that's long gone. Which means what it carries isn't just rare, it's irrecoverable. And unless we can analyze it now, in this moment, we may never get another chance. That's orbital mechanics. That's why some astronomers are worried. Because this could be a chemical fingerprint from another part of the galaxy. And if we lose that fingerprint without understanding how it works, we lose more than just a research opportunity. We lose a message. The leaked images weren't supposed to be public. They were part of a quiet internal review. But something about 3I/ATLAS changed that. Because what they show is hard to ignore. A comet that moves wrong, glows wrong, vents the wrong chemicals, and acts more like a machine than a rock. Astronomers aren't alarmed because they think it's alien. They're alarmed because we may not have enough time to figure out what it really is. This might be our only chance to understand why it's breaking the rules. And it's slipping away faster than anyone expected.